parallelograms. Think about your Venn diagram. One starts with an R.
Rhombus.
Okay, the other one also starts with an R.
Rectangle.
What about a rectangle that's also a rhombus?
Square.
Yeah, so we're going to talk about those. The first one is a rectangle. Okay, I made some mistakes on these notes this morning, so hopefully I don't do that again. I've had a practice run. All right, if we have a quadrilateral that is a rectangle, we know it is a parallelogram. I'm just drawing a little parallelogram. So if we have a rectangle, we can conclude it's a parallelogram. If it's a parallelogram, do we know for sure it's a rectangle?
No.
No, so that one's not backwards and forwards. That's just one way. Okay, if a parallelogram is a rectangle, then its diagonals are congruent. So I'm just going to draw a rectangle here. And then I'm going to draw my two diagonals. And when I say, okay, so I'm just going to say that blue is congruent to the pink one. That way we don't have to name them.
What did you do?
Oh, okay, they were already named, aren't they? Okay, here. Well, it gets confusing because if I mark this congruent, am I talking about that whole thing or just that little part? You know what I mean? What? I know that that's what we mean, but do you see how it can be confusing when you're trying to go back to this later? All right, so let's just label it. We'll just label with what they've got. A, B, C, D. And then we can say that, hey, BD is congruent to AC. Okay. So chances are these examples are going to apply those things. We have a rectangular picture frame where JK.
Wait, is it backwards and forwards?
That's a good question. Yes. Thank you. Backwards and forwards. Okay. So if we have a woodworker constructing a rectangular picture frame where JK is 50 and JL is 86, we need to find HM. So what is HM? Yeah. JK. Did I put it in the wrong spot?
Yeah.
Doop, 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 doop. Okay, I will say for myself that we actually don't need that, I don't think, but it's still annoying that I've mislabeled it. Okay, so HM is 86
43.
divided by 2, which is 43 what?
I don't know.
Centimeters. Okay,
Where does it say that?
pick a spot. All right, next one. All right, we want to find HJ and we want to find HK. All right, so what do you think? Well, if GK is 48 and I have a rectangle A rectangle is also a parallelogram, right? HJ would be what?
48.
48. So we know that opposite sides have equal measures. They are congruent.
48 inches, correct?
Thank you. Yes. All right, what about HK? So we know it's a rectangle. What do we know about the diagonals?
They are
So the diagonals are congruent. Okay, so if this little bit is 30.8, isn't this little bit 30.8? Is it in a parallelogram that the diagonals bisect each other?
I guess.
I think it's in a parallelogram. So if we have a parallelogram, we know that diagonals bisect each other. So we know that we can just double the 30.8 and we get what? What? 61.6 inches? Okay. Questions? Okay. So now we're going to talk about rhombi. A rhombus is another special parallelogram. A rhombus is a quadrilateral with 4 congruent sides. So, like a rectangle, a rhombus is a parallelogram. So you can apply all the properties of parallelograms to a rhombus. So everything we did yesterday applies to today. I mean Friday. Okay. All right. So if we know the quadrilateral is a rhombus, then we know it's a parallelogram. Okay, does this one go backwards and forwards? Are all parallelograms rhombi? No, so this one is just one way. Okay. If a parallelogram is a rhombus, then its diagonals are perpendicular. Okay, so just go ahead and do your best to draw a rhombus with diagonals. Ooh, that was not good. This is harder than it looks, guys. Okay. Okay, you have to be careful with this one. This is actually what I messed up earlier today. Don't tell Coach Vogler. This one only goes one direction because there's another figure that has perpendicular diagonals, and that is a kite. So if you think about a kite, it looks like this. Those diagonals are also perpendicular. So if the diagonals are perpendicular, it doesn't necessarily mean that it's a rhombus. We have to also know that it's a parallelogram. Does that make sense? If we know it's a parallelogram and we have perpendicular diagonals, we can say that it's a rhombus. If we only know that the diagonals are perpendicular, we can't say that it's a rhombus because it could be a kite. Cool? Okay. All right. Number last one. Okay. Number middle of the page. I don't know. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. All right. Let's draw the rhombus. Oh my gosh, it's really difficult. So each diagonal is going to bisect these pairs of opposite angles. So this one is getting bisected into two baby congruent angles. This one is getting bisected into two congruent baby angles. And same with these two. So if you have a figure and you have opposite pairs of angles being bisected by the diagonals, I think this one goes backwards and forwards.
How does it go backwards?
If you have a figure and it's marked like this, where if you add these two together and these two together, you get opposite angles congruent, then we know it's a parallel. Do you know what I'm saying? And then we've got the diagonals both bisecting the angles, then it's a rhombus. I think if you did a parallelogram, let's see what a regular parallelogram, like a boring one.
Can I throw this stuff on my desk door?
Okay, so look at this. Do you see how this angle, this is a parallelogram. All right, now. You see how this angle and this angle are not congruent, so that diagonal is not bisecting? So this is specific to a rhombus. Okay.
Now can I go throw that away?
No. Can you just wait till we're done?
Why?
It's not hurting anything. Just
yes, it is.
relax.
It's
Oh my
hurting my
God.
eyes.
Just put it on the floor.
I don't
All
want
right, here we go. We're finding TV. And we're finding the measure of angle VTZ. VTZ, this one. Okay, can we start with the side? Can we start with the side? Okay, so what do I know about the sides of a rhombus?
They are what? Congruent?
Yeah, all sides congruent. So if I could find one side, then I could find this, it's the same as the side I want, right? Okay. Can anyone think of a way that, can you put your phone away? Can anyone think of a way that I could use the given information to solve for a side?
13b minus 9 equals 3b plus.
Yeah, all of these sides are congruent, right? So if I set these two sides, top and bottom, equal to each other and solve for b, I can plug b in and find the length of all of the sides. So I've got 13b minus 9 equals 3b plus 4. I've got 10b. I've got, oh my gosh, is that 13? So I'm getting 1.3 for b. Okay, now pick the easiest one to plug into. I picked the top one. Okay, so 3. So TV is going to be the same as XT, which is 3B plus 4. And I know that B is 1.3. Are we getting 7.9? Do we know units? Okay. Mystery units. All right, let's talk about the angle. If we have a rhombus, what do we know about the diagonals and the opposite angles? Okay, let's start. Okay, let's say, what do we know about the intersection of the diagonals? Hold on. What do we know about what happens when the diagonals of a rhombus intersect? They're perpendicular. So if we have a rhombus, we know that the diagonals are perpendicular. Okay, so how can we use that in this picture? Like, do we know what this angle is right here? 90. Okay, so aren't they all 90? So do I know what the measure of this angle is? This 14a plus 20 is 90. Okay. So I know that 14a plus 20 equals 90. 14a equals 70. Is a 5?
Yes.
Is it 5?
Yes.
Okay. Okay, now that I know A, what do I know about these two angles here? Hold on. What do the diagonals do to the opposite angles in a rhombus? Bisect. So diagonals bisect opposite angles. So these two angles here are the little baby angles. Oh my gosh. What do I know about this angle and this angle? They're congruent. Thank you.
I thought you were asking for that.
No, I'm saying the angles are congruent. We can't just go writing equations without knowing why. I mean, we can, but should we?
Yeah.
No. We've all seen how that turns out. Okay, so I know that these two angles have the same measure. So can I use this expression right here? Yes, because it's the same measure. Thank you so much. Okay, so the measure of angle VTZ is 5 times 5 minus 5. 20 what? Degrees. Okay, I didn't have to put the degrees on the 5 because this expression already has degrees, right? But if I'm asking for the measure of the angle, I need to say it in degrees. Does this make sense?
What if it didn't have it? Like, we get to put 8 equals 5 degrees.
Okay, what we didn't write here was that this has degrees, so you have to keep the degrees. Do you understand what I'm saying? Okay.
Yeah.
Okay. Okay. Next one. All right, we know that this guy is a rhombus. We have to find CD. How can we find CD?
All sides are equal to each other.
Okay, all sides congruent. So their measures are equal. So how can I use that?
3a plus 17 equals 5a.
Yeah, so these two have to be equal in measure. So 5a equals 3a plus 17. 2a equals 17.
8.5.
8.5.
Good job.
Okay, how can we use that?
That's a good question.
Is it 42.5?
Yeah.
Okay.
Wait, what? Wait.
Oh wait, we're trying to find CD. Oh my.
No, we're not. We're trying to find CD, buddy.
Right? Can't I use?
Oh, okay. So if we find the length of one, they're all equal.
Correct.
Oh yeah, I thought that was.
Yeah, but it was pretty rapidly.
Okay, so that's that part. All right, what else do we have to find out? We want the measure of angle CGH. Wait, no. What does that say? GCH?
Yeah. No, UCB. Oh. Yeah.
Okay, so okay, then this one right here. Whoa. No, the big one. This big one.
Is B plus 3.
Yeah. Okay, what about CDF? Where's that? CDF. That's this big one. Woo, monster one. That one is 6B minus 40. Okay, so a rhombus is a parallelogram, right? Right? What do we know about parallelogram angles? The opposite angles in parallelograms are congruent. What do we know about consecutive angles? Yeah. So if we know it's a parallelogram, we know consecutives are supplementary. So I know that B plus 3 plus 6B plus 40 adds up to 180. Okay, it's really distracting having an entire conversation going on right now. It's not fair to the rest of the class.
Minus 40.
Is it my, see, this is what happens. Thank you.
Yeah, it's all your guys' fault.
Not entirely. To be fair, I could have made that mistake on my own, but the conversation didn't help. Okay, so if I add 40 over, I'm at 220, and then subtract 3, I'm at, what, 217?
Yeah.
Okay, now I've got 7B.
Oh, is that a 6B?
Yeah, it's a 6B.
No, it's like a 66.
Okay.
You see 68?
All right, what is 217 divided by 7? What is it? 31? Ew. Okay. So now I can add 3 to it. So this one ends up being what, 34 degrees? And then we chop that in half. So the measure of angle GCH is half of 34, which is 17 degrees. Okay, right now it might seem really arbitrary and like just crazy that if you don't put degrees off, we're getting points taken away. Because right now all you know to measure in is degrees, right? It's like at first when you were a kid, there was only inches and you didn't know about centimeters and all that other fun stuff. Okay, when you get into upper levels of math, you're going to have to worry about radians. So radians don't have a symbol like degrees. So if you don't put the degree symbol, you're talking about radians. And 17 degrees is a lot smaller than 17 radians. 17 radians is huge. Okay, so you got to put the degrees or it means something completely different. Got it?
Yes.
Okay, thank you. All right, guys, we were cruising actually. All right, ready? Hey. Okay, if we have one angle of a parallelogram that is a right angle, then we know it's a rectangle. So if we have a parallelogram, then we know it is a rectangle. If we don't know that it's a rectangle, if we don't know it's a parallelogram, we need all 4 to be right angles. Does everybody hear what I'm saying?
Yes.
If we already know it's a parallelogram, we just need 1 right angle. Okay, if we just know it's a quadrilateral, then we need 4 right angles. Everybody hear the difference?
Yeah.
Okay. I don't want anyone getting confused over that. All right, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. We already knew that. That was one of those ones that's the backwards way of one of the ones that we already knew forwards. So this one is true backwards and forwards. Okay, questions? Okay, conditions for rhombi. Okay,
How many of these are we doing? Like all
a lot. So many. Notice that all of these are saying parallelogram. Parallelogram. Parallelogram.
There's actually another.
This is not true if all we know is that it's a 4-sided figure. We have to know that these are parallelograms to make conclusions based on this information. Does everybody understand that?
Well, is there gonna be like a question on the test that doesn't say parallelogram? Like,
Okay, we'll talk about that in a second. Okay, so if one, yep, if one diagonal, oh, I'm reading the wrong one. Okay, if one pair of consecutive sides of a parallelogram are congruent, then we know that the parallelogram is a rhombus. Hey, here. Okay, if it's just a quadrilateral, how many congruent sides do we need? 4. Okay, if it's just a quadrilateral and we don't know it's a parallelogram, we need 4 sides. If we know it's a parallelogram, we only need 2 consecutive sides. Got it? Okay. If the diagonals of a parallelogram are perpendicular, then we know the parallelogram is a rhombus. Okay, again, it has to be a parallelogram for this to be true. If it's not a parallelogram, it could be a kite, right? We talked about that already. Okay. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Again, we have to know that it's a parallelogram, otherwise this is true of a kite if it's just a quadrilateral. Okay? Okay. So, this is to answer your question. Could we have questions where we're given certain information and like we have to determine whether a conclusion is valid? Yes, it's happening right now. So if it's not valid, we have to tell what additional information is needed to make it valid. So let's mark our given information. EF is congruent to FG. And then EG is perpendicular to FH. EG and FH, those are the diagonals. So is this a rhombus? Okay, I have a very quiet no, but a quiet and confident.
What? What?
Someone is saying no. Do you agree or disagree?
I don't know. I don't know the question.
Okay, so one thing that is very helpful to me when I'm trying to go through this is to ask myself, can I change this picture where the markings and the givens are still true, but to find a counterexample? Because the way that they drew it sure makes it look like a rhombus, right? It looks like it should be true. But they do that to mess with you. So look, can we extend FH? Can we extend Are the markings still true? Okay, so is this a rhombus? I mean, it may or may not be, but we don't know because we don't have enough information. It could be a kite. Do you guys see what I'm talking about? Okay, so I can keep the same markings true and draw this as a kite. So this is not valid. So what would make this valid? What would we need to know? Yeah, if they told us it's a parallelogram, we need to know that EFGH is a parallelogram. Alternatively, if we knew that EH and GH were also congruent to the pair that they gave us, that would also tell us it was a rhombus. Okay, questions about that? Okay. All right, what about this guy? We know that ABCD is a right angle. A, B, what? ABC is a right angle. Do we know that this is a rectangle?
No,
Okay, why not?
because we're not given that it's a parallelogram.
Yep. We don't know that it's a parallelogram. So we're going to say not valid. We need to know that ABCD is a parallelogram. Alternatively, if we knew that the other interior angles were 90 degrees, we could say that it was a rectangle. So we either need all four, like this, or we need to know it's a parallelogram if we only have one. Got it? Okay. All right. Is this our last page?
Yeah.
Yes. Cruising.
Haven't you done this before?
Yeah, but sometimes I get a little lost. It's a little disorienting up here.
Buddy, how are you?
All right, what do you?
On the packet, you can see this last page. How are you all?
Okay. We have four right angles, so we know it's a rectangle. We've got four congruent sides, so we know it's a rhombus. What is this?
Square.
It's a square. So a square is special because we can use all the properties of a parallelogram, all the properties of a rhombus, and all the properties of a rectangle. Okay, that's a whole lot of properties. You know what I mean?
Yeah.
Okay. All right. Whoa. All right, let's mark our given information. EB is congruent to BG. FB is congruent to BH. Okay, what does that tell us? If the diagonals bisect each other,
It could be
more general than a rhombus.
Equilateral.
Okay, go back and look at your 4.1 notes. Yep. Aren't we in 4.2?
No.
Okay, okay. Word vomiting aside, just yelling stuff out to yell stuff.
It was a highly educated.
Uh-huh. If the diagonals bisect each other, we know it's a parallelogram.
Don't believe.
Okay, what else we got? All right, we know that EG is congruent to FH. EG is congruent to FH. So it looks like I have congruent diagonals. What does that mean?
It's a rectangle.
Good. Therefore, it's a rectangle. Okay, last piece of information. We know that triangle EBF is congruent to triangle EBH. So if we know that triangles are congruent, what's true about their corresponding parts? Uh-huh. So do you guys want to use the, hey, do you want to use the sides question mark, or do you want to use these little angles question mark? Sides? Okay, it's probably the easiest to see. So what do we know about these two sides if these two triangles are congruent? They are congruent. Give them 3 things. Okay, so we already know it's a parallelogram. So I've got one pair of consecutive sides in a parallelogram. Congruent, what does that mean?
Square.
Yeah. No, it's a rhombus.
Oh, yeah. God wants to know what the definition of a rhombus is.
What, buddy?
Well, he's welcome to watch this video when we're done making it in 5 minutes.
Me or him?
All of us.
Yeah, it'd be you, buddy.
Okay, so if we know that it's a parallelogram, a rectangle, and a rhombus, what the heck is this thing?
It's a square.
It's a square! Hooray! All right, let's look at this bottom one. Okay, we do have to justify our reasoning on this, so don't just yell stuff without being able to back it up.
I would never do that. See, I knew it was parallel.
Yeah, okay. Sell it to someone who's buying it, buddy.
What?
You heard me. All right, what's
Okay.
this one?
Fine, don't believe me once we get another 99.
Okay. What do you think?
Dude, Rob, why do you keep looking at me? Like,
Okay, tell me why. What are the diagonals doing?
Bisecting.
You don't
Okay.
know that. I didn't know that.
Because they're marked as congruent, bro.
Well, they're bisecting the angles. Not each other.
And the diagonals are perpendicular.
Do we know that on this one?
Oh, wait, no. Not that.
Yeah, see? See?
Well, I'm still right about it being a rhombus.
Yeah. No.
Okay, let's watch the language.
Oh, yeah, that's mine.
Okay. Diagonals bisecting two pairs of opposite angles. So this is a rhombus.
I can't see what it
All right, what about this next one?
Square.
Okay, why?
Because you have the 4 congruent sides and a right angle.
Okay, what do you mean congruent sides?
The ones that have like the four inner ones.
Okay, so are those sides?
Those are bisects.
Okay, so what do we know about these two diagonals? What are they doing to each other? Okay, diagonals are perpendicular. Can we come back to that one?
Yes.
What are they doing to each other? Okay, so diagonals are bisecting each other. So if the diagonals are bisecting, this is a what again? A gram?
Oh, parallel.
Yeah, parallelogram. Okay, now that we know it's a parallelogram, hit it, Elena. Now that we know it's a parallelogram, what you said is important. Because if it wasn't a parallelogram, it could be a kite if you had perpendicular diagonals, right? Okay, so now we know that the diagonals are perpendicular, and we know it's a parallelogram, therefore it's a rhombus. What else do we know? Okay, so look, do I have two ticks here? No. Okay, so what do I know about this diagonal and this diagonal? Okay, so if the diagonals are congruent, then this is a rectangle. Ultimately, it will be a square because it's a rhombus too. So the diagonals are congruent. Therefore, it's a rectangle. So we know that its most precise classification is square. So if it's a rectangle and a rhombus, we know it's a square, right? Okay. All right, last one.
Quadrilateral.
Okay, we know it's a quadrilateral, but we want a more specific name. Is that the most specific? What are the diagonals doing to each other? Oh. So what is this? Therefore, parallelogram. Do we know anything else?
No.
That's all we know. I wasn't supposed to be a trick question. So this one's a parallelogram, middle one's a square, first one was a rhombus. All right, that's all she wrote.